Okay, so what are the machine learning skills that we are going to need in order to work on this course? First of course, we are going to read the tweets. We are going to read our dataset using Pandas library we have. After reading it and get some description of the fields we are going to use, description about the types for each column type or for each attribute type. We are going to do some data pre-processing, which how to prepare and clean, some data cleansing to clean the text and prepare it for machine learning model. After this, we are going to do some data exploration to check what are the common words, what are the common fields that we are going to use in our machine learning model to feed our machine learning model with it. Data exploration can show us also the outliers. What are the outliers that we have in our data sets? And the correlation, we can do the correlation between different attributes. The fourth part is machine learning modeling. This is the easiest part for sure, because it's we have sklearn, which include some ready-made or on-the-shelf models that we are going to use directly. We can use and try. We are going to try some classification models, just like random forest. We can also we can try logistic regression, neural network. We can check many different modeling machine learning models or classification models to do the sentiment analysis. And the last part is to do the testing accuracy, and to test our accuracy for each machine learning model we are going to use. How we are going to differentiate between or to decide what is the best model we are going to use is through testing accuracy, through the different metrics we mentioned later here, which are repol and precision and F1 score, and we are going to tell you about them more in the during the course itself. And the last thing we are going after that we are going to do some hands-on, which I expecting you to do to download new dataset, Twitter dataset or any dataset, any feedback dataset. And you can apply the same. You can apply the machine learning models, different machine learning models, and show me your the metrics and the best model. What is the best model you got the best accuracy for it and using it? Okay, and data sources you can find free data sets. You can find it in Kaggle for sure. Kaggle data sets. You can find many data sets for restaurants, for hotels, for many reviews, any reviews for Facebook posts, Twitter posts. It's not only for Twitter. You can bring in any data set and apply the machine learning model, the sentiment analysis on it. And you have also DataGov for data government, some government data sets. You can do it through this website. And the last thing I'm going to do is to review and revise your code and provide my suggestions and some corrections if any. Okay, so let's start. Of course, before we start, if any question, if you have any question, I'll prefer to if it's related to our the subject or the point where we are focusing on during our explanation or lecture, I will be happy to hear. Or it's better to move it to the last of the course. I will collect all your questions or all your feedback and answer it one by one. Okay, so let's start. First of all, we will import everything. We'll import all libraries that we are going to use here, as we explained before. NLTK, word count for and also plotting, regular expression, sklearn, okay, for logistic regression, for metrics, okay, for some machine learning techniques we are going to use. Also, we are going to import vectorizers, which will vectorize our text into NumPy arrays or into matrices, because as you know, machine learning is working on numbers or matrices, not on text. We are going to try the counter vectorizer and the TF-ID IDF vectorizer. Let's start by reading the text. Okay, by reading this text, you will find, okay, we have no module. Okay, of course we didn't install word count. It's easy, which is easy. We can install it using pip install word count. So it's successfully installed. No module core. Okay, and for this we should restart our Jupyter notebook in order to find it there. I will restart it again. Okay, let's close this user page. Okay, let's try again to import it. It's got imported, no problem. Now we have the TF-ID, the word count installed. Let's check some information about the dataset. Now we imported some dataset called tweets. Tweets dataset. It's some tweets collected from the internet, from Twitter. We can explore it here directly. We can explore some of the tweets. What are the fields included? As you can see here, we can find some tweet ID. We can find airlines, airline sentiment. Okay, so the tweets about airline, it's airline company or airline organization. What is the name of the poster or the account? What is the text of the tweet? What is the text coordinates? Coordinates for sure. The map coordinates or the country from where, yani the place or the country this account is posting. Tweet created, the date of the tweet. Tweet location, also it's the country or the location itself, just like Canada or US or whatever. User tweet zone, it's the zone, what is the time zone of this tweet, of this user. So this is simply some data we can find here, around 15,000 record or tweets. Okay, so we already create a data frame from this data set and explore the info is providing us with some information about data fields and and the number of records we have. For example, tweet ID we have, those are the numbers we have. Tweet record, tweet coordination, for example, we have some null values here, it's around only 1,000, only around 1,000 have only the coordinates. Okay, and also the location, we don't have much of location here. We also have around 10,000 only, and the time zone also we have. It's not. It has some null values. Okay, this is give us some brief about the data. Let's try to describe. Okay, for description here is giving us some indicators about the outliers and the mean. What is the mean of the data? What is the standard deviation? We can found it here. What is the minimum values of each column, of each attribute? Okay, max and min, and so, and what is the top value? You can found it here, and the frequent of this top value. For example, airline sentiment, we have only three for sure. Okay, we have and the positive or negative or common or normal, for example, and the top tweets we have, it is negative. The top sentiment we have is negative, and the top poster we have is JetBlue News, and the top text we have is thanks. Okay, thanks. This is the top text that we have on our tweets. Coordinates is 0000, which are null values, not defined, for example. Most of our tweets created around 1150, which is a little bit rare because it's not that yani around 6,000. Okay, we have it to this value. Okay, and the tweet location, the top, most of our tweets created from Boston. and time zone is US Canada. Okay, so let's check some sample 5 record of our dataset. As we can find here, that we found the tweet ID, airline, sentiments was neutral, positive, negative. Those are the 3 values that we have. What is the name of the account or the user? What is the text itself? We can find here some mentions. Okay, what is the tweet coordinate? What is for sure? If you press head here, head will give you the first 5 record. If I want to increase, I can make it 10. For example, it will bring the first 10 records. If I didn't define anything, the default is 5. Or I can also put tail. Tail will give me the last 5 records of our example. Okay. Let's explore our categorical data. What are the categorical attributes that we can work on it, right? We can find it here. For example, categorical, يعني for sure you have it. It's some static text or static data or predefined values, which or predefined categories. يعني so all values from those categories. There is no free text. There is no يعني it's supposed to be from one of the categories. For example, you have here airline sentiment. Okay, we can visualize it, we can explore it. Also, it's a categorical data, and also we have يعني this is the best column actually, or the best attribute we can explore here. Like, it has categorical data. For sure, we can also explore the time zones, we can explore the locations, we can do this. However, we are going to visualize the air sentiment. Okay, as you can see here, we have the most of our sentiment, most of our tweets is classified as sentiment is as negative, and also please don't forget for sure it's a labeled data. Okay, to train our classification model, we should use labeled data. What I mean by labeled, you should mention the sentiment here. The sentiment is already mentioned. Neutral, positive, negative. It's already mentioned. Okay, because in order this is يعني a classification problem. It's not clustering problem. It's a classification, and in order to do the machine learning modeling, we should have a labeled data. Okay, so as you can see here, most of our tweets is negative. Okay, and for sure you know the classification is it's a okay. It's a supervised learning, and it's a category of supervised learning, not unsupervised. For unsupervised learning, you can do something like clustering, which doesn't need any label data. It's unlabeled data. But for this problem or this classification, it's supervised. That's why we have already. We should bring a labeled data set. So back to our point here. Okay, we have negative يعني so many negative posts other than neutral or positive. The least post or sentiments we have is positive. This is the lowest amount. Also the location. Let's visualize the location or category. Let's group the locations. We have around 157 from Boston. We have and the counter is going down. This is ordered by number. So Boston is the biggest one, has tweets, and the next to Boston we have New York and Washington. Okay, what is the use of this visualization and what is the use of this exploration? It will give us يعني a brief about the data, an understanding of the data. What are the outliers? What are the maximum? Do we have any bias? Do you have any bias in our data? Do you have any what is the variance on our data? Is it variant enough to create machine learning, or we should bring more generalized data, more different data from different locations to have best machine learning model or better machine learning model? Okay. Also here for time zones, okay, we have those are the values that we have. Most of it from Eastern time, then Central time, then Pacific time. And for the name, we have the top poster or top user is JetBlue News, and after that the other is coming. So during this, we did some exploration, as I mentioned, to check the outliers, to check the maximum values, the most repeated ones, or top records that we have. Okay. The next step in our machine learning project is to do some pre-processing. What I mean by pre-processing in text in general, we need to clean the data. We need to clean this text. So for example, let's check the duplicates. Here the records. What is the shape is giving us? Shape is giving us number of records by multiplied by the number of columns. So we have 8 columns and 14,640 records. We can sort data to remove the duplicates. We should sort the data by text, okay, and drop the duplicates, and okay, in place to keep the IDX or the index of the record, and remove the rest of duplicates. We don't need duplicated data. This is the last thing you need in machine learning model. It will create bias in our data. It's okay. So we should remove the duplication. This is the first thing we should take care of on cleansing. After that, we check the shape again. The shape we have data dropped to we have missed about 300 records or something, duplicates. After removing duplicates, we go to the second step, is to handling null values. Okay, machine learning is not good with null values. As I mentioned later, that we are going to convert all this text to matrices, to numbers. So if you have nulls, it will give you very sparse metrics we don't need, and it gives bad accuracy in our machine learning model. So handling null values, okay, we will check the shape here, which is not null. What are the name? Let's check the not null or the null values in name, in text, on coordinates or location, in time zone. Okay, so this is the null. We don't have any null values in name or text, but we have a location and time zone. Okay, so this is the current shape, and we have something very interesting here in our library, which called fill in A. Fill in A, we have in our data frame, fill in A, it will fill the null values with this value. It will fill the null value with none. It give it a none. So in this case, it's not null. It has a value which is none. Okay. We give it a category here. So this is fine because we have a text. At least we have a text. We are going to convert it to a machine learning matrix, or feed it to our or NumPy matrix. Feed it to our machine learning model. We are going to print the shape again. Now we don't have any null values here. If you can check, we are exploring the not null, or okay. So we have 0 0 in time in tweet location and user time zone. We don't have any null values here. It's a 0. Okay, and let's explore a record here. Okay, from our location, I'm just testing a record to find not it's none or none. Okay. After that, we don't have to use. We are going to use any mentions. Okay, any mentions here, we are going to remove it, because it could noise our machine learning here. So we're going to remove it using the regular expression. If we have any word started by this at, okay, and so we are going to remove the rest of the word. Okay, so after removing it, I will found all Teddy tweet. We created a new column called Teddy tweet. So this is the original tweet. This is a Teddy tweet. Okay, for example, here's this record. We don't have American Air here. It's not found here, so it's moved. After that, we are going to remove the punctuations, numbers, special characters. We don't need this on our text. We should remove all this in order to have a pure text for machine learning text. We are going to convert it to NumPy array. So we have this regular expression to replace any not. This is in regular expression. This is not. Okay, any not A to Z, or capital or small, or that. So any non-character or non-alphabetic, we are going to replace it with null value or empty. So this should remove it, and we should place it on the Teddy tweet. And for sure, we also leave this hash because hash, as you know, is giving us some idea about the trend. So we need the trend. If we don't need the trend, we can remove it also. So here we can find any punctuation, any dots, any like this. It's cleaned. The text itself is cleaned from any other than alphabetic and hash. We also can remove short words. Short words also should be removed. So for any word, the length, if the length of this word is less than three character, we should remove it. We should remove it. Okay, and store it on the Teddy tweet. Okay, so a lot of short words, a lot of these short word, number 2 character or 3 character, will also noise our machine learning model. It will not give us a good accuracy, so that's why we should remove it. Then after do this cleansing, we are going to tokenize. What I do by tokenize, we are going to convert we are going to split every tweet. We are going to split it in different words, on some words. So tokenized tweets, by mean here, it will convert it to array. It will convert it to array of words for every tweet. Just like you said here, this is the tweet converted to some text, some words. After we convert every tweet to array of words, we are do some stemming. What I mean by stemming here, stemming simply is to return the word to its original or root word. Okay, so we are doing this to have some normalization. We're doing some normalization on top of data. This normalization will give better and better accuracy to our machine learning model. Whenever you have scaled data and normalized data and clean data to your machine learning model, it will provide you with more accurate and confident machine learning result or accuracy. So we're going to apply here, what we are going to apply is a stemmer on every word we have for every tweet. We are going to do the stem, or to apply the stemmer on every word. Okay, so for example, you'll find guy, months, fleet. If you return, for example, months, it's months now. Okay, you will find extremely, it's extreme, volume without E. The porter stemmer it's a little bit dummy. It's removing the last E of the word, or removing it, remove some characters from the last of the word to bring it to the base character, only the base character of the words, which is not the best stemmer, but this in our case it's good. It's enough to use. Then we are going to aggregate it again after this tokenizer. We are going to aggregate it after the stemming. We are going to make every tweet as a text, full phrase again. So we did this, okay, combining our words into a phrase again in the Teddy tweet. Let's after that to check our tweets. What are the common words that we have using the word count? Okay, you have defined some parameters here. Random state, max font. Random state is a state you should define in order for every run you should find the same result. And if you change the random state here, you will find different result after that. It's a statistical parameter. Yeah. So and this is also the max font. Generate all words, and all words were coming from we split the data tweets to words again, and give it to the word count to measure or to generate the common words here. Okay, then we use a matplot library to visualize it. So as you see here, those are the top common words we have. You can see flight, you can see plane, cancel, need. Those are the most common. Either positive or negative or normal. You can find it here. We can after that we can visualize all positive words. Okay, so simply we are filtering all words. We are filtering it by the attribute air sentiment. We have it on our database. So only collecting the positive words or the positive feedback or positive tweets, and after that we visualize those words from the positive tweets here. So we can find thanks, we can find awesome, crew, help, love. We can find something like that. Flight for sure it's not I don't see as a positive يعني, but it is classifying the post at all as positive, so you can find this word a lot, which makes sense to see it here. And also we can find the all negative words the same. We filtering with negative and visualize with word cloud, filtering by word, or generate common words by word cloud and visualize it again. We can see something like cancel. We can see wait, please, customer delay, for example. Yes, we can find some negative words here. Okay. After that, let's start the machine learning process, which we should start it by dividing our data set into training set and test set. Okay, and to do this we have sklearn function, which is a train test split. It's a sklearn function to split our data set into two parts with 20%. We are going to use 20% for test 20% for test size, with random state also 42. This is, as I mentioned before, it's just a statistical parameter. It has nothing to do. You can set any seed. It's a seed of our random state. You can use any number here, okay, to split our data set. So this is the length of our training set, and this is the length of our test set by 20% and 80%. Now we do some feature engineering. Okay, we use feature engineering here, which features, which columns we are going to use, and how to vectorize, create, or to convert our text into numpy or matrices, arrays or numbers we are going to feed it to our machine learning model. So in order to do this, it's better to use TF-IDF. TF-IDF is vectorizing our words or our machine or our tweets by the most important word in all documents. So it's measuring the most important words in all documents and vectorize or convert it to numbers. For example, sublinear here. So those are some parameters. Okay, and you can use it and explain it more in future courses. Mine data frame, and what is the normalization vector or factor, encoding, it's Latin or English. Ingram, for example, it's from 1 to 3, and Ingram means يعني what is the tokenizer length, يعني every 2 character, every 3 character, every 1 word, or every 2 words. It's this is a splitter, يعني, or the number of words for each split. And what are the stop words? Stop words we are going to use, or for sure for here. NLTK has some a dictionary of stop words, just like the, to, is, at. We are going to remove all those short stop words in order also to have better accuracy. And then we fit transform our features. Fit transform will take our features and convert it to machine learning features or matrices. Okay, so we give it the tweet, the Teddy tweet, which we created before. This is the clean text we need to vectorize it. This is the clean text we need to vectorize using the TF-IDF vectorizer. Okay, and our labels should be this column. Our label should be the sentiment. So this is a shape. This is the shape we have. We have this number of rows, and with this number of features. So number of features, we have all those fields as number of feature, creating from this vectorizer, which is converting our text to a bag of word. A bag of word splitted or organized by the most important words in all documents or all tweets we have. Now it's time to build our model. And to build our model, this is a vectorization we're going to use. We use something called data frame mapper. Data frame mapper is combining the vectorizer of the Teddy tweet that we created before, TF-IDF vectorizer. Okay, and adding some more features. We only took one feature with the Teddy tweet, but also we can add some other features to our machine learning feature, just like the name, and the vectorizer of it could be TF also TF-IDF vectorizer. Tweet location also, it's a text. We can for any text we can use TF-IDF vectorizer. So we added those features to our machine learning model we are going to use, and create and do the mapper fit transform, which will transform all our data or all those features to the machine learning features we have here. Then we create a evaluation set. In our evaluation set, okay, categories. What are the categories that we have? Categories we have three categories: negative and positive and neutral. Okay, we took it from here. Okay, so we create also we did this again. We did this again to split our features, but using we did it before. We did before for the tweets DF directly, but we are going to do it now after the features, after this vectorizer, after all features are vectorized, okay, with the TF-IDF. So we are going to split it again with those features, with those labels or categories, and this is the test side and this is the train side, 80% and 80%, 20%, and this is a random state we have. Now let's check the accuracy. Check the accuracy using confusion metrics, using accuracy score and classification report. Okay, so for example, we can print it directly. Let's execute all this from top to bottom. Okay, we are here. Okay, so let's run all above. Okay, we run all above. This is the evaluation record. And this is the accuracy we are going to. This is the function we are going to use to test our accuracy. Why we created a function here? Why it's not a normal code? Because we created a function to be able to use it at many locations here to test with different machine learning model. So for each machine learning model, we are going to print the accuracy using this function directly, and instead of rewriting the code again for every machine learning. So for example, here we are going to use the random forest machine learning model. So we are going to import it and create a classification from random forest classifier and fit our x and y. X for sure is the created here. X is our training set and y is the training set. So you are going to fit our x and y with this classification model and print the accuracy. Okay, so x is not defined. Okay, we are going to run this. Okay, so yeah, this is not defined. Okay. Aha. We are missing something here, I think. Let's run all again. Okay, we have a word count. I'm not sure why word count is not defined, because it was already defined here.